So, greetings everyone. This is Pranay Babu Totakura with Z number Z237-21377. Today, I'm here to discuss on the scalar trigger processing, which I have constructed from the given articles and I have demonstrated it. Now, coming into the outline of the presentation. The outline of this presentation majorly consists of the motivation to this article. So, this motivation is majorly the terminology that is used in this article, and the conceptual understanding of the articles are the key concepts in this. The problems in the problem definition, I have defined the number of problems that are there in this article and how they are being addressed. And coming to the challenges, and the challenges basically consist of how the problems are being are being solved, and the difficulties that are solved, difficulties that have arisen while doing the while doing the problems. Now coming to the related work, how the whether the given arranged problems have been solved before, or if they are solved before, how they are related to the current project. And coming to the proposed approach and algorithms, it consists of the number of algorithms that are used to solve the problem. And coming to the validation process, in the validations, we use the computational complexity of the article that are being tested. And finally, we conclude the presentation with some of the future work. And now let us go into the motivation process. In this, the web-based applications are used in this article. And these web-based applications, they majorly create the triggers interactively. Some of the examples of these web applications are they optimizes SQL queries, and they also uses the indexing strategies for implementation. And many of the web-based applications uses stock ticker notifications. The limitations to these web-based applications are the current trigger systems used in the article are not scalable by their nature.
All right, go.
And this also consists of the traditional uses of triggers. The schema level triggers. The schema level triggers, these can be created by any user of your current database. Coming to the row level triggers, the row level triggers are these row level triggers fires once for each row that is affected by a triggering event. The column level triggers are whenever these are used after the row level triggers, the new column value has already been stored in the table. And now, after that, in the traditional uses of triggers, we check the constraints, we use the login operations and the log off operations, and also the replications of these operations are being used. The key concepts that are being used in this article are the triggerman architecture. In this triggerman architecture, we basically use the four types of trigger creation steps, and these trigger creation steps use the stock ticker notification. Let us suppose say the triggerman client app, it uses the trigger1 application to create the trigger1, and in this trigger1 we store the data such as create trigger t1 from the stock notifier s1. When the stock ticker is Google is GOOG, which is the short form of the Google, and stock value is less than 500, we will notify the person with the value p1. Similarly, while creating this trigger T2, we demonstrate it as create trigger T2 from the stock when stock.ticker is equals to Microsoft MSFT, which is a short form of Microsoft, and the stock value is less than 30. We will notify the second person with P2 value. Similarly, while creating the trigger T3, we'll create it as Oracle, which is ORCL for the short form of the Oracle, and stock value which is less than 20, we'll notify the person P3. And T4 trigger, it consists of one constant value, which is only the stock.ticker as GOOG, and we will notify the person P4 when that trigger is being created. Now coming to the expression signature. This expression signature commonly uses the common structures in the conditions, whether for the respective triggers. Suppose let us say T1, T2, T3 triggers uses two constant values, and T4 trigger uses one constant value. If the T1 trigger is being used, then the for T1, T2, and T3 triggers, the common structure that is being used is stock.ticker is equals to constant 1 and stock.value which is less than constant 2. This common structure is being observed throughout the T1, T2, and T3 triggers, and stock.ticker is equal to constant 3 is being observed in the T4 trigger, and in that trigger stock.ticker is equals to only one constant value that is being used. Now, now let us discuss about the key concepts which are in the A-treat network. For the A-treat network, for the each trigger condition, we use the following trigger condition as stock.ticker is equals to constant 1 and stock.value which is less than the constant 2 value. And we can say from the given figure that as we use two nodes as the predicates, and the node values consist of the two nodes are majorly the alpha nodes, and the node values of the node 1 is stock.ticker is equals to constant 1, and the node value of the node 2 is stock.value which is less than constant 2. Now coming to the expression signature table. In this expression signature table, we generally use both two types of expressions such as even ticker value and E2 ticker value. In the E1, we use constant table variable as const underscore E1, and the E2 we use const underscore E2 as the constant table. And the number of constants that are used in the even table are 2, and the number of constants that are used in the E2 table are 1. And both of the constants tables are being stored in the main memory. And now coming to the constant tables that are being used in the even ticker table, stock ticker tables are const E1 and const E2. Suppose let us say in the const even table we use total two types of variables, and in const E2 table we use only one type of constant table. Suppose let us say the two types of constant values are in the constant one we store the values as Google, Microsoft and Oracle, and in the constant 2 we store the values such as 530 and 20. Coming to the second ticker value, where there is only one constant table, we use only Google as the constant value, and null in the second constant table. So we can say that the next node which is being stored in the constant 2 table is null. Similarly, this can be observed from four of the triggers such as in the T1, T2, T3 trigger, the common structure is being is being observed such as it has constant 1 values of Google, Microsoft and Oracle, and constant 2 values such as 530 and 20. In the T4 table, we can only observe one constant table that consists of the value Google. Now let us consider the key concepts that are in the predicate index. The given figure shows the predicate index values in which the data source forms the predicate indexes, and this data source gives the values to the predicate index root, which are being extracted from the expression signature list. Now coming to the processing of the predicate index, we update the stock whose ticker value is Google and the value is 495. And this root has two nodes, and from one of the node, it consists of the index of the ticker value, and in the other node, it consists of the predicate index source. And this source majorly consists of the three types of triggers, where the triggers majorly consists of the values that are being stored in Google, Microsoft, and Oracle with the constant two values, which are 530 and 20. Now coming to the final overview of the key concepts. In the A-tree network, we have used the network for trigger condition testing, and the condition for this A-tree network is that all of this must be true for a trigger, then it has to be fired. Now coming to the expression signature, the common structure in the trigger is even for the even signature expression, the stock.ticker value is equals to constant 1 value, and the stock.value should be less than the constant 2 value. Now coming to the constant tables, the common value has to be the constants for each expression signatures are the constant table values. The problems defined. The problems defined in this article are: they are relational database management systems, the trigger statements, the data streams which are in the form of tokens. We need to find the triggers that are corresponding to the each token, and our main objective is to do it in the scalar trigger processing system. Coming to the constraints, these constraints are mainly different trigger expression structures. Each distinct trigger expression structure should be small enough to fit in the main memory location. Coming to the challenges, in the validations it provides experimental comparisons, and coming to the testing complexity, the complexity is being tested on the real data sets. The example for these kind of validations is the execution trace. We also remove the sections in the challenges such as from the trigger man command language and the architecture. And we also describe the A-treat network that we have already been discussed. The related work to this article is being extracted from the references such as Gupta 89 and Hello 98. From the Gupta 89 and Hello 98, we have extracted the parallel processing, and from the and AI is being extracted from the smaller rule set of the Forge 82 and Mira 87 articles. So these articles work is the combination of improvised version of some of the modules that are mentioned below. And now contribution to this article is that whenever creating an extensive number of triggers, we'll find that a lot of them have nearly the same format with the most significant contribution. The concurrent processing, it takes 4 levels of concurrency. So in these 4 levels, the token level concurrency has been implemented. Now let us come back to the validations of the article. In the validations, we use the key facts such as whenever the significant number of triggers which are being made, a lot of the triggers will have nearly identical formats. And the main primary validation that is being used in this article is that we use a Informix data blade, and also there are no experiments that are being compared to the given validations. Finally, let us conclude our presentation. In conclusion, we can say that we use the token level concurrency, and because it has a better scalability and also better performance even on a single processor. And we can say that whenever there are many number of triggers that are being created with the distinctive signatures, and many of the triggers will have nearly identical formats. And now these are the references that are being used in this presentation, so that it helped me to demonstrate my project. Thank you.